Hello. So, quick recap from yesterday. Find the expansion of your 1 over 1 minus a third x all to the power 3 in ascending powers of x up to and including the term x squared. So this is just like the kind of questions you were doing yesterday. So just to recap your skills, the first thing you would do is rewrite it in a way that we understand. So you can use your binomial expansion. So it's got a negative power, so you need to use this formula. It's all good because you have a 1 there. So pause the video, just check you can do it. Here's your answer. Okay, don't forget your condition of validity. So that would be rewritten. That's not okay to leave it as that. You need to leave it as the modulus of x is less than 3. That would be fine. Or even better, so that you can visualize it, x lies between 3 and negative 3. And we will be talking more about that tomorrow. So I'll just straighten that up there, make it a bit clearer. Okay. Right, so today's lesson. What if there isn't a 1 in the bracket as the first term, right? What if you don't have a 1 there, okay? Your formula is only for that situation if there is a 1 there. So if you were asked to expand something like this, currently you can't do it. You don't have a formula to do that. You can't use the one that you used in year 12 because that's only for whole number positive powers. So you're going to have to do something so that you can use this formula. So what you're going to do is you're going to think about your laws of indices. Now you've been working with indices for a long time. You know that 3x all squared is really 3x times 3x, 9x squared. Or if you prefer, everything in that bracket is raised to the power 2, so 3 squared and x squared. Similarly here, if you had 5y squared, 5y squared all cubed, then everything inside that bracket is cubed. You're going to have 5 cubed and you're going to have the y squared cubed. So that would simplify to be 125 y to the 6. So we have this law of indices. If you have AB all raised to the power n, that is the same as a to the n times b to the n. And that's the trick we're going to use. So here we have something that we want to expand using the binomial, but we need to get it ready first. The problem is that is a negative power, so you can't use the year 12 version of the binomial, right? If that was a nice positive power, you could bang those in straight away, but you can't. You can't use your formula because the 2 is there. You need a 1. So this is what you're going to do. You're going to take out a factor of 2, but you're going to do it really carefully. So what I've done is when I've taken out a factor of 2, I've introduced another set of brackets, because what I'm afraid of doing and what I can't do, I can't just take things out of brackets that are raised to a power. So I've kept the power of -1 outside. I've kept the power of -1 there. Sorry, I've just knocked that. And I've taken out the factor of 2. So I've divided that by 2 and I've divided that by 2. So be careful not to forget to divide your x by 2. So what you've now got inside this outer set of brackets, I've written them as squared brackets, is you've got 2 to the power of -1 and 1 plus x over 2 to the power of -1. So you can now split up that expression. Okay, 2 to the -1, 1 plus x over 2 to the -1. Now we know 2 to the -1 is just 1 over 2. Obviously that should be a half. I haven't underlined that. I'll do that quickly so I don't forget. And I'll print it off for you. So you've got a half, 1 times 1 plus x over 2 to the minus a half. So what you'll now do is you'll be able to expand this using your binomial, and at the end you'll multiply everything by a half. We'll do that in a minute, but we'll just do this one step at a time. Here's another example of getting ready to use a binomial expansion. Okay, it's got to be the year 13 formula because that power is a half. However, you can't do it straight away because that is not a 1. You're going to have to divide all through by 4. You're going to take out a factor of 4. Okay, do it inside that bracket first. So I've taken out a factor of 4 and I'm left with 1 plus 3x over 4. Obviously, you can't, the 4 can't disappear because this is an expression. It's not an equation. It's not equal to anything. So it has to stay there. It's just outside the bracket. And now that is raised to the power of a half, and this bracket is raised to the power of a half. So you've got 4 to the power of a half times 1 plus 3x over 4 to the power of a half. And then all you're going to do is you work out what 4 to the power of a half is. Well, that's the square root of 4, which is 2. And that will then be multiplied by your binomial expansion that you would then go on to do. But we're breaking this up first. So what you're now going to do is pause the video. You are going to write these expressions in a form where you are ready to use the binomial. You're not going to do it, you're just going to get it ready so that there is a 1 there. So pause the video, do those 3 questions, please. Okay, here are the answers. So all I've done here is I've got these ready. You can see I took out a factor of 4 here, but it was 4 to the power of a half. So it became 2. Please remember that you must divide that term by whatever you're taking the factor out of here. Here I took out 3 to the negative 2, which of course is a 9th. And here I rewrote and I took out 2 to the minus 1, which of course is a half. So that's you getting them ready, okay? Let's now go to our next little bit. So here's an example. So find the first 3 terms of this expansion, the square root of 4 plus y. We want the first 3 terms in ascending powers of y in this binomial expansion. Obviously it's not x, it's y, it's still the same thing. So first thing I'm going to do is I'm going to rewrite using brackets. Now, I can't use my formula, although that's a half, so I have to use the year 13, the A2 formula, the one we've been using, but that's not 1. So I'm going to take out a factor of 4 to the half. So first of all, I take out the 4, remembering to divide everything by 4, and then I raise them both to the power of a half. You know that 4 to the power of a half is 2. So what we've done here is we've worked that out as 2, and then you've used your formula that you were using in yesterday's lesson at the beginning of today's to find your first 3 terms of your binomial expansion. You've obviously got your trusty calculator by your side. You would put those into your calculator, making sure everything's okay. And then at the end, you will multiply all through by 2. So you've got 2 plus y over 4 minus 1 over 64 y squared. Part B. Part B asks for the condition of validity, so your modulus bit. Now, it's really important that you use the value that got put into the binomial expansion. So it's not this y here, it's this y over 4. It's the y over 4 that was put into the binomial expansion. So it's that modulus that has to be less than 1. So you use that value. So you get the modulus of y over 4 being less than 1. Now, we never leave it like that. So what we do is we multiply both sides by 4. So acceptable answers for that last part would be the modulus of y is less than 4, which obviously means y lies between 4 and negative 4. Example 2. Now you can see here that example 2 is an exam question and it was worth 5 marks, which is quite a lot of marks. So you've got to expand this 2 plus x to the minus 2 up to and including x cubed, extending powers of x. State the set of values for which it's valid. Now, of course, you have to use your year 13 formula because that power is negative, but that's not a 1. So you're going to use this new skill where you take out a factor of 2 to whatever power there is. So if you take out 2 to the negative 2, you can see that I may remember to divide everything inside that bracket by 2. I know that 2 to the negative 2 is a quarter. And then inside this bracket, I've used my binomial expansion by putting those into the formula. I've got my calculator ready to shove those in. It's not that nice. So I've simplified that expression. And what I've done here is I've sort of annotated the mark scheme. So there was various bits where you were hitting marks to get those 5 marks. And then I'm going to multiply everything by a quarter. So that is your binomial expansion. You're now going to write the condition of validity. Now remember, it's not that, it's the bit that actually goes into the binomial expansion. So you use the x over 2. So for that last bit, those last marks, it's valid for x over 2. The modulus of x over 2 is less than 1. Again, that's not good enough. You multiply both sides by 2. So this would be absolutely perfect. The modulus of x is less than 2, or x lies between 2 or negative 2. Okay, right. If you could pause your video, we have a set of questions here. So you've got question 1, question 2, and quite a lot of work in question 3. So again, you'll have a PDF of these questions. So I've put a little star by D because it's that little bit harder. So make sure you pause the video and do these questions as though you were in a lesson. Here are the solutions. Notice that if it hasn't actually asked for the condition of validity, you probably don't have to give it. It obviously won't hurt you to. But these ones, they've just been interested in the expansion. Okay, slightly harder. So example 3, find the first 3 non-zero terms in the binomial expansion of 1 over 4 plus x squared, and state the range of values for which the expansion is valid. And you can see from B that this is just going to be one of the uses that we're going to be able to do here. We're going to be able to get an approximate value of an integral that in A-level maths, there's going to be no stage in our A-level maths that you're going to be able to integrate this. Further maths, yes, but not in A-level maths. But so you can see what great things the binomial is going to enable you to do. So the first thing in A you're going to do is rewrite it in the format that we know. We know because that's a negative power, we've got to use the A2 formula. No good, because that's a 4. Take out 4 to the minus 1, and you're left with x squared over 4. Now, the only reason this is a little bit harder is because that's an x squared, so you're just going to have to be that more careful. You're then, obviously, 4 to the minus 1 is a quarter. You're then going to substitute this into your binomial formula that you're given, and then you're carefully going to work it out. So when you've carefully worked it out, you can see you've got a quarter minus 6 x squared plus 1 over 64 x to the 4. Remember, so again, a little bit nastier, you're going to have the modulus of x squared over 4 is less than 1. So that means that the modulus of x squared is less than 4, which means that the modulus of x is less than the square root of 4. So the modulus of x is less than 2, or x is between 2 and negative 2. Right. Part B. Find an approximate value of that integral. Now, of course, you could put that into your calculator and that will give you an exact value, but they know that, and that is not what they've asked. So you're unlikely to get any marks if you do that. By all means, do it as a check to check that your answer isn't absolutely far off, but they have clearly told you to use your expansion and you are getting an approximate value for this, not an exact value. So all you would do is you would get the answer that you got for your integral, and for your expansion, and you would simply integrate that. You know it's not going to be exact because you've stopped it. You know that that's going to go on and on forever, and of course you're not going to integrate forever. So all you do is you integrate the terms that you got from your binomial expansion. That's all integration that you could have done in year 12. Raise the power by 1, divide by the new power, and you simply substitute 1 and 0 in. So your answer is 0.198. Again, you could put that into your integral function on your calculator to check that you're not too far off with your approximation. And then, didn't mean to do that, here are a couple of harder questions. So pause the video, have a go at these questions. They are that little bit harder. Question 2 in particular asks you to do a little bit of understanding. When you've done those questions, the answers are on the next bit. So here are your answers. And if you want, I've also put the worked solutions in as well. Well, that could be do with coming out a bit. So here are your worked solutions. Sort that out so you can see it a bit better. So your worked solutions. Okay, well done. See you tomorrow.